This is SpaceTime, Series 29, Episode 13, for broadcast on the 30th of January 2026. Coming up on SpaceTime, the Milky Way supermassive black hole hiding its violent past. A new study shows the water makeup of Jupiter's Galilean moons was set during their birth. And evidence that meteor impacts have been triggering dust avalanches on the red planet Mars. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Our Milky Way galaxy's central supermassive black hole, Sagittarius A star, has long been considered a quiet, sedate creature. However, a new study, reported in the astrophysical journal Letters, suggests that may not always have been the case. Sagittarius A star is located at the centre of the Milky Way galaxy, about 27,000 light-years away from our solar system. It's reasonably small by supermassive black hole standards, with a mass of around 4.3 million times that of the Sun. That makes it a lightweight compared to other supermassive black holes, which often have billions of solar masses. We often think of Sagittarius A star as being quiet and sedate. But rather than being a shy wallflower, X-ray emissions observed by the XRISM Space Telescope are now suggesting that Sagittarius A star appears to have flared dramatically sometime within the last few hundred to maybe 1,000 years. These surprising findings are unveiling new details on how supermassive black holes evolve. And they're also teaching astronomers lessons about our own cosmic history. The study's authors measured X-rays coming from a giant gas cloud near the galaxy's centre, using XRISM's ability to resolve the energy of individual X-ray photons. Their findings offer strong evidence that the cloud is glowing in response to a past outburst from Sagittarius A star. One of the study's authors, Stephen de Kirby from Michigan State University, says many supermassive black holes are bright because the gas around them heats up and emits high-energy radiation. In contrast, Sagittarius A star barely shines at all. It's one of the dimmest known supermassive black holes in the universe, and only visible because it's so close to Earth. There are several large molecular gas and dust clouds floating around Sagittarius A star, and they can act as sort of cosmic mirrors, reflecting past X-ray flashes from the black hole. Previous space telescopes could detect these glimmers, but not with enough energy resolution to examine their fine structure or determine what likely produced them. And that's where XRISM comes in. It's changed all that. The telescope was launched in 2023 through a partnership between NASA and the Japanese Aerospace Exploration Agency, JAXA. Its first observations were highly anticipated because they're a vast improvement over existing space telescopes in terms of energy resolution. Most X-ray space telescopes can distinguish the energy of a photon to about 1 part in 10, maybe even 1 part in 100. But XRISM can resolve them to 1 part in 1,000. The authors use this sharp view to zoom in onto extremely narrow X-ray emission lines coming from one of the molecular clouds orbiting the central black hole. By measuring their energies and shape with groundbreaking precision, astronomers could determine the cloud's motion and match it to previous radio observations. They also examined subtle features in the spectrum to test two competing theories about the cloud's glow. And those new details have ruled out the idea that cosmic rays were responsible. And instead, they showed that the cloud is reflecting an X-ray outburst from Sagittarius A star, effectively a light echo from the past. By studying multiple clouds at different distances from the black hole, astronomers can reconstruct a timeline for when these ancient flares occurred, much like using delayed echoes to map the shape of a cave. By resolving the ion lines with such clarity, astronomers could read the galactic center's past activity in unprecedented detail. This is SpaceTime. Still to come, a new study has shown that the differing water content of Jupiter's 4 large Galilean moons was established as they were being formed and not from some later evolutionary processes. And scientists have observed how meteor impacts on the red planet Mars can trigger dust avalanches. All that and more still to come on SpaceTime. A new study has shown that the differing water content of Jupiter's 4 large Galilean moons was established as they were being formed and not from later evolutionary processes. The new findings, reported in the Astrophysical Journal, can help explain the striking contrasts between these distant worlds. For example, while Io, the most volcanically active moon in the solar system, appears completely dry and devoid of all water ice, its near neighbour Europa is thought to harbour a vast global subsurface ocean of liquid water. In fact, it makes them look like they came from completely different families. So to try and determine what's going on, the authors tested 2 main hypotheses to try and explain the differences. The first suggests that the extreme conditions prevailing close to Jupiter during satellite formation prevented water ice from being preserved, thereby depriving the moon Io of this component from the very outset. The second hypothesis proposes that both Io and Europa initially formed with similar amounts of water, but Io subsequently lost most of its volatiles over time through atmospheric escape and erosional processes. The authors reconstructed the earliest evolutionary stages of both Io and Europa, assuming that both moons' water originated from hydrated minerals incorporated during formation. Using an advanced numerical modelling framework, the study coupled the inertial thermal evolution of the moons with volatile escape processes, accounting for all the major heat sources active in the young Jovian system. That included accretional heating, radioactive decay, tidal dissipation, as well as Jupiter's immense radiation. One of the study's authors, Olivia Mouses from the Southwest Research Institute, says Io has long been seen as a moon which lost its water later in life. But when the authors put the idea to the test, the physics refused to cooperate. Io simply can't get rid of its water that efficiently. For that matter, Europa wouldn't lose its water either, even under extreme conditions. The findings indicate that Io and Europa were already fundamentally different at birth. Io forming from dry materials, while Europa accreted from ice-rich building blocks. These models indicate that the compositional contrast between Io and Europa isn't the outcome of subsequent evolution, but rather the direct legacy of the primordial environment surrounding Jupiter at the time its moons were formed. This is SpaceTime. Still to come, a new study claims dust avalanches caused by meteor impacts are generating dark scratch-like streaks on the surface of the red planet Mars. And the constellation of Orion the Hunter, the red supergiant Betelgeuse, and the Pleiades or Seven Sisters Open Star Cluster are among the highlights of the February night skies on Skywatch. A new study claims that dust avalanches caused by meteor impacts are creating dark scratch-like streaks on the surface of the red planet Mars. The conclusions, reported in the journal Nature Communications, are based on analysis of scratch marks on the edge of Apollinaris Mons, an ancient 5-kilometre-high shield volcano located at the boundary of the Martian northern plains and the planet's southern highlands region. The European Space Agency's ExoMars Trace Gas Orbiter captured what appears to be dust avalanches on the slopes of the mountain the night before Christmas in 2023. The data from the colour and stereo surface imaging system on board the spacecraft also shows the faint cluster of impact craters in a discoloured region at the base of the slopes. Additional imagery helped scientists determine the impact and streak formation occurred sometime between 2013 and 2017. Scientists believe these streaks occur when layers of fine dust suddenly slide off steep terrain. With no evidence of water, they've concluded that these features mostly result from dry processes driven by wind and dust activity. The findings, reported in the journal Nature Communications, suggest that this is a rare event, with fewer than 1 in 1,000 streaks caused by rocks smashing into Mars. The study's lead author, Valentin Bickel from the University of Bern, says in most cases seasonal changes stirring up dust and wind are to blame for these sorts of streaks. He says dust and wind and sand dynamics appear to be the main seasonal drivers of slope streak formation. He says meteor impacts and Marsquakes seem to be locally distinct, yet globally relatively insignificant drivers. Bickel used deep learning algorithms to analyse more than 2 million slope streaks in images from NASA's Mars Reconnaissance Orbiter. The resulting streak census located them in 5 distinct hotspots on Mars between 2006 and 2024. He says the observations could lead to a better understanding of what happens on the Martian surface today. This is Space Time. This episode of Space Time is brought to you by Squarespace, the platform that makes building an incredible online presence not just possible, but effortless. Squarespace gives you all the tools you need to create a professional website, claim your perfect domain, promote your brand, and even get paid, all in one easy-to-use place. Squarespace's design tools give everyone the power to create a website that looks like it came from a top-tier design studio. And to make sure people actually find your beautiful site, Squarespace includes SEO tools that work in the background. Think auto-generated sitemaps, optimized page structures, and customizable meta descriptions, so you appear in the search results where it matters. Now, if you want to see how easy it is to bring your ideas to life online, visit squarespace.com/spacetime for a free trial. And when you're ready to launch, use the code SPACETIME at the checkout to save 10% on your first purchase for a website or domain. That's squarespace.com/spacetime, promo code SPACETIME, and of course we have a link in our show notes.
You're listening to SpaceTime with Stuart Gary.
And time now to turn our eyes to the skies and check out the celestial sphere for February on Skywatch. February is the second month of the year in the Julian and Gregorian calendars. It's also the shortest month of the year, and the only one which is a length less than 30 days. The month is 28 days in common years and 29 in leap years, with a quadrennial 29th day being called a leap day. This additional day every fourth year is needed to keep the calendar year synchronized with the astronomical year. Because seasons and astronomical events don't repeat in whole numbers of days, calendars that have the same number of days in each year tend to drift over time with respect to the event the year is supposed to track. By inserting an additional day every fourth year, this drift can be corrected. The extra days occur in years which are multiples of 4, with the exception of years divisible by 100, but not by 400. Similarly, in the lunisolar Hebrew calendar Adar Aleph, a 13th month is added 7 times every 19 years to the 12 lunar months in its common years, in order to keep its calendar from also drifting through the seasons. And in the Baha'i calendar, a leap day is added whenever it's needed in order to ensure that the following year begins on the vernal equinox. The length of a day is also occasionally changed by the insertion of leap seconds into Coordinated Universal Time, or UTC, more often referred to as GMT or Greenwich Mean Time. This is needed because of the variability in Earth's rotational period. But unlike leap days, leap seconds aren't introduced on a regular schedule, since the variability in the length of the day is not entirely predictable. Okay, let's turn our attention to the sky now. And throughout most of February, sky watchers in the southern hemisphere may be lucky enough to catch sight of the occasional meteor associated with the Alpha and Beta Centaurids meteor showers. Now, as their names suggest, they appear to radiate out from the direction of the constellation Centaurus as 2 separate streams, although they rarely produce more than 1 or 2 meteors per hour. They usually peak around February the 8th, and to see them at their best, you really should be looking towards the east a few hours before dawn. Okay, looking north now, and high in the sky is the famous constellation of Orion the Hunter. Orion is one of the best known and most recognized constellations in the sky. In Greek mythology, Orion was the son of a Gorgon and Poseidon, who was also known as Neptune, the god of the sea in Roman mythology. Orion was a mighty but egotistical and conceited hunter, who once boasted that his skill would allow him to kill all the world's animals. So the earth goddess Gaia sent Scorpius the scorpion to kill him and save the animals. Orion was stung in the shoulder, but then the healer Ophiuchus intervened to save him and crush the scorpion. Both Orion and the scorpion were then placed in the heavens to play out the story each year, with Scorpius rising in the east as the defeated Orion sets in the west. Now, a variation of this fable speaks of Orion getting a little bit too close to Artemis, the goddess of chastity. Now, her brother Apollo didn't approve of this relationship and tricked Artemis into testing her skill by shooting an arrow at a distant speck on the ocean. What Artemis didn't know was that speck was actually Orion, swimming to escape the giant scorpion created to kill him. When Artemis discovered what she had done, she placed Orion's body in the sky as the stars we see today. similar variations to this story appear in other cultures, including ancient Egypt, where Orion is known as Osiris, the god of the underworld and of regeneration. The very earliest depiction that's been linked to the constellation Orion is a prehistoric mammoth ivory carving found in a cave in the Arch Valley in West Germany in 1979. Archaeologists have estimated that it would have been fashioned somewhere between 32,000 and 38,000 years ago. The distinctive pattern of Orion has been recognized in numerous cultures around the world, including ancient Babylonian star catalogues dating back to the Late Bronze Age. Orion's easily identified by its rectangle of 4 stars, surrounding a central trio of stars in a row which form Orion's belt. And hanging from the belt are the stars which make up the Sword of Orion. To those of our listeners in the Southern Hemisphere, Orion appears to be upside down, with the sword on his belt pointing upwards. And if you look really carefully, you'll notice that the middle star in the sword looks a bit fuzzy. That's because it's not a star, but rather a huge star-forming region known as Messier 42 or M42, the Great Nebula in Orion. Located some 1,344 light-years away, M42 is the nearest large star-forming region to Earth, containing hundreds of newly forming stars and protostars. A light-year is about 10 trillion kilometres, the distance a photon can travel in a year at 300,000 kilometres per second, the speed of light in a vacuum, and the ultimate speed limit of the universe. The Orion Nebula is more than 24 light-years across, and it contains as much mass as 2,000 suns. It's one of the most scrutinised and photographed objects in the night sky, and is among the most intensely studied celestial features. The Orion Nebula has revealed much about the process of how stars and planetary systems are formed from collapsing molecular gas and dust clouds. By studying M42, astronomers have directly observed protoplanetary disks, brown dwarfs, intense and turbulent motions of gas, and the photoionizing effects of nearby massive stars in the nebula. The Orion Nebula contains a very young open cluster known as trapezium due to the asterism of its 4 primary stars. The trapezium itself is a component of the much larger Orion Nebula cluster, an association of around 2,800 stars within a diameter of just 20 light-years. The brightest star in the constellation of Orion is the semi-regular variable red supergiant Betelgeuse, which represents the scorpion sting on Orion's shoulder. Currently known as Betelgeuse, and commonly referred to by the public as Betelgeuse, don't say it 3 times, the names are both tortured mispronunciations of the original Arabic name Ibtal Yauza, meaning the hand of the big man being Orion the Hunter. Located some 643 light-years away, Betelgeuse is the 9th brightest star in the night sky. And it's big, really big. In fact, red giants like Betelgeuse are among the largest stars in the universe, at least in terms of volume, although they're by no means the most massive or luminous. Calculations of Betelgeuse's mass range from slightly under 10 to a little over 20 times that of the Sun, and it shines with some 100,000 times the Sun's brightness. If it were placed at the location of our Sun at the centre of our solar system, its visible surface would extend almost as far out as Jupiter, engulfing the orbits of the planets Mercury, Venus, Earth and Mars, as well as the main asteroid belt. Betelgeuse began its life around 10 million years ago as a spectral type O or B blue star. Astronomers describe stars in terms of spectral types, a classification system based on temperature and characteristics. The hottest, most massive and most luminous stars are known as spectral type O blue stars. They're followed by spectral type B blue-white stars, then spectral type A white stars, spectral type F whitish-yellow stars, spectral type G yellow stars, that's where our Sun fits in. Then there are spectral type K orange stars, and the coolest and least massive stars are spectral type M red stars, often referred to as red dwarfs. Each spectral classification system is also subdivided using a numeric digit to represent temperature, with 0 being the hottest and 9 being the coolest, and then Roman numerals added to represent luminosity. Put them all together, and our Sun is officially classified as a G2V or G25 yellow dwarf star. Also included in the stellar classification system are spectral types L, T and Y, which are assigned to failed stars known as brown dwarfs, some of which were actually born as spectral type M red stars, but became brown dwarfs after losing some of their mass. Brown dwarfs fit into a category between the largest planets, which are about 13 times the mass of Jupiter, and the smallest spectral type M red dwarf stars, which are between 75 and 80 times the mass of Jupiter, or about 0.08 solar masses. Red supergiants are fascinating objects. After spending billions of years fusing hydrogen into helium in their core, a star's core hydrogen supply eventually runs out, and the balancing act between nuclear fusion pushing outwards and gravity pushing inwards stops, with gravity winning. The entire mass of the star then comes crashing down onto the core. This causes a dramatic increase in the core's pressure and consequently temperature. Things get hot enough to trigger what's called a helium flash. This causes the core helium, which has been created in the star, to begin fusing into carbon and oxygen. At the same time, the hydrogen-rich region around the stellar core has now moved down into that region where the temperatures and pressures are high enough for hydrogen fusion into helium to commence in a shell around the core. Now, as all this is going on, the increasing core temperature results in an increasing level of luminosity, and the resulting radiation pressure from the shell burning causes the outer diffuse gaseous envelope of the star to expand to hundreds of times its previous radius. And as the now bloated star's chromosphere or visible surface moves further away from its core, it cools down, turning redder. Hence the star has become a red giant. Small stars like the Sun eventually lose their outer envelopes completely, which continue expanding outwards as planetary nebula. This ultimately exposes the star's white-hot stellar core as a white dwarf, which is then left to slowly cool down over the eons of time. However, stars with masses more than around 8 times that of the Sun experience a very different fate. Unlike the Sun, their fusion cycle doesn't end with helium in the core fusing into carbon and oxygen. They have enough mass to fuse carbon and oxygen in their core into progressively heavier and heavier elements through a different process, while the shell burning around the core also fuses progressively heavier and heavier elements. Carbon, nitrogen, oxygen, neon, magnesium, silicon, sulfur, nickel, and eventually iron. These stars have become supergiants. Eventually they'll explode as core collapse supernovae, ending up as either super-dense strange objects called neutron stars, or even stranger objects called black holes. Singularities of infinite density and zero volume, where the laws of physics as science understands them no longer apply. It's too early to tell whether Betelgeuse's ultimate fate will be as a neutron star or black hole. As a red supergiant, Betelgeuse is reaching the end of its life, and it's expected to explode as a core collapse or Type II supernova any day now. Of course, in astronomical terms, any day now could mean tomorrow, or it could mean 1,000,000 years from now. When it does explode, Betelgeuse will temporarily outshine all the other stars in our galaxy, and it will be clearly visible in the daytime sky on Earth. The last star to be seen by humans to go supernova in our galaxy was Tycho's star. That was in 1572, and that was before the invention of the telescope. Diagonally opposite Betelgeuse, marking Orion's left foot, is the blue supergiant star Rigel, the second brightest star in the constellation Orion. Rigel is part of a triple or possibly quadruple star system with 3 or 4 small companion stars. The primary star, Rigel A, is located some 863 light-years away and has about 23 times the mass of the Sun. The star's already exhausted its core hydrogen supply, and it's swollen out to between 79 and 115 times the Sun's radius, and is somewhere between 120,000 and 279,000 times as luminous. Like Betelgeuse, it's now fusing progressively heavier and heavier elements in its core, meaning it too will soon go supernova. Rigel A pulsates quasi-periodically and is classified as an Alpha Cygni variable star. Alpha Cygni variables are variable blue or white supergiant stars which exhibit non-radial pulsations, meaning some areas of the star's surface are contracting while others are expanding. This causes irregular variations in brightness due to beating of multiple pulsation periods. The pulsations are likely caused by iron opacity variations and typically have periods ranging from several days to a few weeks. Rigel A's companion star, Rigel B, is some 500 times fainter than the supergiant, and it's only visible with a telescope. Rigel B itself is a spectroscopic binary system comprising 2 main sequence blue-white stars. Main sequence stars are those happily fusing hydrogen into helium in their core. And spectroscopic binaries are double star systems orbiting each other so closely and at such an angle that they can only be visually separated, at least from our viewpoint on Earth, by their spectroscopic signatures. The two stars making up Rigel B are estimated to be 3.9 and 2.9 times the mass of the Sun, respectively. And one of those stars, Rigel BB, itself may be a binary. It appears to have a very close visual companion, Rigel C, of almost identical appearance. The third brightest star in Orion is Bellatrix, Orion's left shoulder. It's a spectral type B main sequence blue star, with about 8.6 times the mass and 6 times the radius of the Sun. Bellatrix is located about 250 light-years away. It has an estimated age of approximately 25 million years. Now that's old enough for a star of this mass to have consumed much of the hydrogen in its core and begin the process of evolving away off the main sequence into a blue giant. One of the most stunning nebula in Orion is the spectacular Horsehead Nebula, Barnard 33. The Horsehead is a dark nebula located just south of the star Alnitak, which is the furthest east on Orion's belt, and is part of the much larger Orion Molecular Cloud Complex. Located around 1500 light-years away, the Horsehead Nebula was first recorded in 1888. It's one of the most identifiable nebulae simply because of the shape of its swirling clouds of dark dust and gas, which really does bear an incredible resemblance to a horse's head. To the west of Orion's belt, you will see a V-shaped grouping of stars which represent the head of Taurus the bull, who in Greek mythology was changed by the god Zeus to carry Princess Europa off to Crete. The V is also part of a large open star cluster known as the Hyades. One of Taurus's eyes is the giant orange star called Aldebaran, or the Follower, which is located around 65 light-years away and has about 1.5 times the mass of the Sun. Aldebaran is thought to contain a number of Jupiter-sized planets. Aldebaran's already evolved off the main sequence, having exhausted its core hydrogen fuel supply. It follows the Pleiades, or Seven Sisters, a spectacular open star cluster to the northwest of the V. Located in the constellation Taurus, the Pleiades is one of the nearest and youngest open star clusters to Earth, located just 443 light-years away. There's a story in Greek mythology which tells us that Orion fell in love with the Seven Sisters and pursued them for a long time. Eventually, Zeus turned both Orion and the Pleiades into stars. Interestingly, a similar story is told in the Aboriginal Dreamtime culture of the Great Victoria Desert region near Aldea in outback South Australia. Orion's described as a young male hunter who chases but never catches the Pleiades, who are a group of 7 young women. In Orion's right hand is a club filled with magic fire and represented by the red giant star Betelgeuse. However, the Pleiades' older sister, represented by the Hyades star cluster, taunts Orion, standing in front of him. She defensively lifts her foot, which is the star Aldebaran, and is also full of fire magic. And this causes Orion great humiliation, putting out his fire and allowing the Seven Sisters to escape. Now, one of the interesting facts about this ancient Dreamtime story is that it accurately describes the variability of Betelgeuse, which brightens and fades over a 400-day period. The Pleiades' Seven Sisters story is remarkably similar to legends found in many other cultures around the world, and which haven't had any contact with each other for tens of thousands of years. The Pleiades' 7 brightest stars can be seen with the unaided eye, hence the Seven Sisters nickname. But this spectacular open star cluster actually consists of more than 100 stars. Now, if you follow Orion's belt to the east, it brings you to Sirius, one of the nearest and brightest stars in the sky. Located just 8.7 light-years away, Sirius is a binary star system with a spectral type A white star orbited by a white dwarf. It's the brightest star in the constellation Canis Major, the Great Dog. In Greek mythology, Sirius was the dog star and the canine companion of Orion the Hunter. To the ancient Egyptians, Sirius was known as the god Anubis, lord of the underworld, who had the head of a dog and who invented embalming, the funeral rites, and who guided one through the underworld to judgment, where he attended the scales during the weighing of the heart to determine one's fate in the afterlife. Later, Anubis was replaced by Osiris as lord of the underworld. Sirius also represented the god Isis, and ancient Egyptians initially based their calendar on the star's yearly motion across the sky. Now, if you look high in the southern sky in February, you'll see the star Canopus, a white supergiant located 313 light-years away, and the second brightest star in the night sky after Sirius. In Greek mythology, Canopus was the helmsman of the Greek king Menelaus, and the brightest star in the constellation Carina, which represents the keel of the boat used by Jason and the Argonauts in their quest for the Golden Fleece. Located nearby are the vessel's sails, represented by the constellation Vela, and the roof of the boat's rear cabin or poop deck, which is represented by the constellation Puppis. Also in the southern skies this time of year, you'll see the large and small Magellanic Clouds, which are two dwarf galaxies orbiting our own galaxy, the Milky Way. The Magellanic Clouds were known to the Polynesians and Maori and served as important navigation markers. They're named in honour of the Portuguese navigator Ferdinand Magellan, who was the first European to sight them during the first circumnavigation of the Earth between 1519 and 1522. Magellan himself didn't complete the circumnavigation. He was killed in the Philippines during the Battle of Mactan. Right now, the Large Magellanic Cloud is located almost directly overhead and is about 163,000 light-years away. Although it looks like an irregular dwarf galaxy, astronomers have classified it as a disrupted barred spiral. It's around 14,000 light-years in diameter and contains about 10 billion times the mass of the Sun. Located slightly lower and to the west, you'll see the Small Magellanic Cloud, which is located around 200,000 light-years away. It's classified as an irregular dwarf galaxy, about 7,000 light-years wide, with about 7 billion times the mass of the Sun. Astronomers speculate that it too was once a barred spiral galaxy, but had become disrupted by the gravitational tidal perturbations of the Milky Way. And joining us now for the rest of our tour of the February night skies is senior science writer and Sky and Telescope magazine contributor Jonathan Nally.
G'day, Stuart. Yeah, February, fantastic time of the year to do stargazing, at least where I live, I suppose, where it's summertime and the weather's really nice. It is a really good time if you like bright stars, because February brings with it a scattering of the brightest stars, as you can see in the whole night sky. In fact, February is the perfect month because 10 out of the 15 brightest stars are all visible at once, at least as seen from the southern hemisphere. So first up, we have Sirius, which is the brightest star in the night sky. It's actually a binary system, so it's not a star, it's a binary star system, but you can't see the companion star. For those who are stargazing from mid-southern latitudes, Sirius is almost directly overhead at about 10 p.m. daylight savings time at this time of the year. To the south of Sirius is the second brightest star in the whole sky. That's called Canopus. And Canopus is actually intrinsically brighter than Sirius, many, many times brighter than Sirius, but it's a lot further away. It's about 310 light-years away compared to Sirius at 8.3 light-years. So Sirius does appear to be brighter, but yeah, intrinsically Canopus is much, much, much brighter. And that's often the way with stars. Some of the bright stars you might see in the night sky might not be the brightest intrinsically, but they're just closer. And vice versa, you can have a star that's very, very bright, but it's a long way away, so it appears to be dim. Now, way down near the southern horizon are two bright stars that are known as the pointers, or the two pointers. And these are Alpha Centauri, which is the third brightest star in the night sky, and Beta Centauri, which is the 11th brightest. Alpha Centauri is a triple star system, and its three components are the closest stars to our solar system. You've got Alpha Centauri A and B, and then another little tiny one called Proxima Centauri, which is actually the closest star to the Earth. Now, if we ever devise a way to send a spacecraft to another star, like Jupiter 2 did and lost in space, although they got lost, the Alpha Centauri system will be the logical first choice because it is the closest.
How could you get lost? It's right next door.
It's right next door, I know. Of course, we all know what the reason was for. You remember?
Oh, the pain.
The pain, yes, the unexpected extra payload on board, which threw them out of whack.
And the robot going nuts as well didn't help.
Well, they tend to do that, robots in space, don't they? You've got that and HAL.
AIs are now suffering from mental distress and torment because people are treating them badly.
Oh, that's Marvin the Paranoid Android. There you go. And don't forget the fellow who was the science officer on board the Nostromo in the first Alien movie. He was a robot, so it's an AI essentially.
Right.
Yeah, so it's a worry, these things. I hope they don't have any AI things on board Artemis 2 heading for the moon.
Well, the rollout just happened, and the countdown for the launch date's underway.
It is. Fingers crossed everything goes well for them. Good luck to them. It's going to be absolutely magnificent. So getting to the moon's hard enough, but imagine going to Alpha Centauri. I mean, I hope someone could do something like that in our lifetime, but I won't be holding my breath. But anyway, that's the nearest star system. On the opposite side of the sky, as we look up, we are low down on the northern horizon, as seen from the southern hemisphere, is the sixth brightest star in the sky. And this one's called Capella. This one's a quadruple star system made up of two gravitationally bound pairs, all of which are about 43 light years away from us, which is pretty close in space terms. Now, about halfway between Capella and the point directly overhead, as you're looking up, again, as seen from the southern hemisphere, is the constellation Orion. Now, you can see Orion in the northern hemisphere as well, so don't worry about that. You can spot it quite easily. Now, this constellation has two very bright stars. You've got Rigel, which is the seventh brightest star in the sky, and Betelgeuse, which is the 10th. What we see as the blue, or the bright blue Rigel, is actually just the brightest of at least four stars in the system. So it's another quadruple system. Betelgeuse, Rigel is blue, Betelgeuse is red, a rich red colour. And it was recently confirmed to have a small companion star, which astronomers have been trying to find for years.
Oh, yes, indeedy do. We did cover that.
It's quite amazing. It's funny, that sometimes these little companion stars are so close to their what would you call them, their host stars, or their big brothers or big sisters, that they are really hard to spot. There might be tantalising hints that they are there, but they can be very, very hard to detect, even in 2026. Anyway, about halfway up the horizon, or from the horizon in the northeast, is another really bright star. This one's called Procyon, and it's the eighth brightest star in the night sky. And it too is a binary system, and it's very close to Earth at a distance of about 11 light years. That's really right next door as far as stars go. On the opposite side of the sky to that, about halfway up from the southwestern horizon, is Achernar, which is the ninth brightest star. So you can see this is a really good time of year to be looking for bright stars. Achernar is famous actually for having a very high rotation rate. It spins on its axis really, really fast. And it's so high, in fact, this rotation rate, that the star has flattened at its poles and expanded at the equator. So it's an oblate shape rather than spherical. So it's a squashed circle. You squash it from the top and bottom. Or you get a balloon and you squash it from two opposite sides. It sort of pokes out of the middle and squashed at the top. So, yeah, imagine that, an entire star spinning so fast that it actually changes its shape. Now, back up in the northern half of the sky, about halfway up from the northern horizon, we've got Aldebaran, which is the 14th brightest star in the night sky. This is another binary system, but its companion star is very small and very faint, and a fairly long way from the main star. It's about 700 times the distance between the Earth and the Sun. Now, those are the bright stars of the February evening sky, but if you're up early in the morning, you'll be able to see another couple of really bright stars too. About a third of the way up from the northern horizon, again, as we see it from the southern hemisphere where I am, we've got a star called Arcturus. This is the fourth brightest star in the night sky. Now, and about another third of the way up from the horizon again, so about 2/3 of the way up from the northern horizon, you'll find the 16th brightest star, which is Spica. Arcturus, the fourth brightest, it's a red giant star that's much, much bigger than our sun. Spica is another one of these binary systems where the two stars are talking about the other one. The Spica has a binary system. Two stars are so close to each other. I mean, really, really close. They orbit each other in just 4 days. So they're so close that their gravity has pulled each of them not into a sort of oblate shape, but into an egg shape. Each of them is drawing the closest side of the other star toward it. So they're each turned into an egg shape rather than spheres. Can you imagine that two enormous stars orbiting so close that they can't see them apart? They're so close, and they orbit just in 4 days' time, and they've pulled each other into an egg shape. It really is quite amazing. So there you go. There's a whole bunch of bright stars to see during February. It's a really good time of year to do that. We've got 10 of the 15 brightest stars visible in the evening, and another couple in the early morning hours. So if you get a chance, go out and have a look for some of them. And because they're nice and bright, you're not going to miss them. They're very easy to see. Now let's have a look at the planets. It's a bit sparse with the old planets at the moment because Mercury, Venus and Mars, well, they're a bit of a write-off, I'm afraid, being lost in the glare of the sun. So we've really got only two planets to fall back on, which are the two gas giants. As evening begins, you can see Saturn for about an hour or so only for about an hour, low in the west. So as the sky's got dark and the sun's gone down and the glow of sunset is disappearing, you'll see a bright thing that looks a bit like a star, fairly low on the western horizon. That's Saturn, and it's only going to be up for about an hour or so before it too dips below the horizon as the Earth turns. On the other side of the sky, we've got in the northeast, but rising higher as the night goes on, is Jupiter. Now, Jupiter is big and bright, very hard to miss. It's, the moon will be up at various times during the month, but aside from the moon, which is a pretty recognisable object, Jupiter, which just looks like a bright star, is really, really bright, and you really won't be able to mistake it for anything else that's up there in the night sky. So have a look at it if you get a chance. And if you get a chance, with both of those planets, Saturn and Jupiter, if you've got a little telescope, or maybe the neighbour's got a telescope, or the school, or someone you know, try and have a look through, because with Saturn you'll see some bit of the rings, even though they're very edge-on to us at the moment. And Jupiter, you should be able to see some of the little tiny pinpricks of light on either side of the planet that are its biggest moons. The 4 big moons, called the Galilean moons of Jupiter, are very easy to see. You can even spot them with binoculars. They don't look like a moon, they just look like a tiny pinprick of light. But when you look through something, say, a pair of binoculars at Jupiter, you're looking through an optical instrument that's even better than Galileo had, but you get roughly the same sort of view that he had, and from which he worked out that these little dots of light orbit the planet Jupiter. And setting off, it's a long story, but it basically helped set off the entire scientific revolution, because it overturned the whole idea of, the heavens are perfect and everything revolves around the Earth.
Yeah, it helped set off the Pope and the Catholic Church as well, didn't it?
Yes, well, refusing to believe or even consider the evidence. In some cases, refusing even to look through Galileo's telescope because they didn't want to have their ideas overturned. Anyhow, Stuart, that is the night sky for February, and we'll be back next month with more.
That's senior science writer and Sky and Telescope magazine contributor Jonathan Nally, and this is Space Time. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from SpaceTimeWithStuartGarry.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to SpaceTimeWithStuartGarry.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.